Okay, next is this strange type of problem where we have these constants c and k, and we're trying to find out which values would make the function continuous. So using our definition of continuity, we know that the limit as x approaches something from the left has to be equal to what it approaches from the right. So in this case of the piecewise function, we have to set this value of x plus 2c equal to 3cx plus k at x equals -2, the limits. So if we have the limit as x approaches -2 of x from the left, because we're coming from the left, because this is when x is less than -2. So on a graph, that would be coming from the left, of x plus 2c. And to do this, we just plug in -2 because there's no 0 in the denominator. So then we have that equals -2 plus 2c. So now we have to set that equal to the limit as x approaches 2 from the right of this part here of 3cx plus k. And that equals, if we plug in x equals -2 for x here, then we get -2 times -3 is -6, -6c plus k. So now we know that, I'll write it up here, -2 plus 2c equals -6c plus k. So we'll keep that up here for use later. But for now, we're going to move on to the next discontinuity or possible discontinuity, which is at x equals 1. So now if we look over here, these functions, it's a different function from the left and from the right at x equals -1. So we want to set the limits equal to each other. So the limit as x approaches 1 from the left just means that we're using this function of 3cx plus k. And now if we plug in 1 for x, we get that equals 3c plus k. And then the limit as x approaches 1 from the right, now we're going to use this function, because this is the function from the right, of 3x minus 2k equals, now we plug in 1, we have 3 times 1 is 1. 3 times 1 is 3. 3 minus 2k. And we need to set these equal to each other, so we'll write that up here. And we'll get 3c plus k equals 3 minus 2k. Okay, and now if you notice, this is a system of equations, which we remember from algebra. And now we're going to solve for our two unknowns, c and k, and that's going to give us the values for which this function is continuous. So there are a few methods we could use. We could use the elimination method, or we could use substitution. So I'm going to choose to use substitution because if we notice up here, we have a k that's on its own and the rest of the variables are c's. So I'm just going to isolate this k. So we'll have k equals, we're going to move this -6c over to the other side, -2 plus 8c, because 2 plus 6. And now we're going to plug that value of k into this equation. So first, let's organize this equation a little more so everything's on one side. 3c plus 3k, because it's -2, and then we're moving it over here. So 2 plus 3k, 2k plus 3k, 1k is 3k. and that equals 3. So now we're going to plug this value of k in over here. So we'll have 3c plus 3 times -2 plus 8c. Now I'll continue over here because I'm running out of room. Now if we distribute this, we'll have 3c, 3 times -2 is -6, and then 3 times 8c is 24c. So now, and that all equals 3, So now we combine like terms and we have 27c equals, we'll move this -6 onto the other side here. So now we'll have 27c equals 9, and c equals 9 over 27, which is just 1/3. So we know one of our values, c equals 1/3. C equals 1/3. Now, all we have to do to find k is just plug that value of c back into one of these equations. So let's choose this one just because it's here. And if we do 8 times c, which is 1/3, minus 2, we'll have 8/3 minus 2 equals c, equals k. So k equals, wait, I'll do it somewhere else. K equals 8/3 minus 2. And if we rewrite 2 as 6/3, so we can get a common denominator, then we have 8 minus 6/3, which is 2/3. And down here we'll get k equals 2/3. And then these are our answers up here. Now, if we want to, we can try to plug these back into the equations to see if they work. So here, if we plug in c is 1/3, we'll have 1/3 times 3 is 1, so x plus k, and k is 2/3, so x plus 2/3. And if we plug in -2, -2 plus 2/3, then we'll get -6/3 plus 2/3, -4/3 from on this part. And then if we plug in for c up here, 1/3, we'll get 2/3 plus x, which is -2. Well, that's the same thing that we did before, and then these parts are equal. So this is a problem that could show up on the AP exam. It's a lot of work to do, as you can see with my crowded screen here, but this is a way that they can test your knowledge on continuity. So make sure that you remember limit from the left equal to the limit from the right, and these values are equal to the function.